Hi guys, so in this video we'll be seeing about the electric field due to dipole at the axial point. So these are the dipole as we can see it over here. So this is a positive charge and this is a negative charge separated by the distance of 2a. So we shall name the midpoint as O and the axial point, the axial line extends to this side. So we shall draw some dotted lines over there and mark P. So the A, right? The electric field due to this would be, as this is positive, this would also be positives repel, so this would go towards right side, and as this is positive and this is negative, this would come attract this charge. Okay, so O to P would be R. We shall take O to P is R. So what would be B to P? R minus A, right? Half of this is A, so R minus A, and this whole thing A to P would be R plus A. Get it? Okay, so then our E minus Q is much greater than E plus Q. Why is that? Because see, from the diagram you can say it is obvious in the diagram actually. So look, E minus Q, see the distance over here is very less, right? Lesser than this E plus Q, right? So lesser the distance, greater the charge, right? So I'm sorry, it went out of focus. So yeah, E axial line of point equals E minus Q minus E plus Q. Okay, so from the formula for electric field we would be getting E minus Q, I'm very sorry. E minus Q equals 1 by 4 pi epsilon naught Q by R square. Here the R is R minus A square. See, R minus A the whole square. This is along PB, so we shall write that too over here. The same thing we shall follow for E plus Q charge too. E plus Q equals 1 by 4 pi epsilon naught Q by R square. The R is R plus A over here, so we shall write it as R plus A the whole square. This is along AP, right? So we shall write that too. So the A axial, the same thing. A axial equals E minus Q minus E plus Q. So while substituting these two equations over here, we will be getting E axial equals 1 by 4 pi epsilon naught Q by R minus A the whole square minus 1 by 4 pi epsilon naught Q by R plus A the whole square. So as Q and 4 pi epsilon naught are common, we shall take that out. So we would be getting Q by 4 pi epsilon naught into 1 by R minus A the whole square minus 1 by R plus A the whole square. So what does this look like, guys? A plus B into A minus B. What does that look like? What does that sound like? So A square minus B square, right? It sounds like A square minus B square. So from that formula we would be getting Q by 4 pi epsilon naught. We are also taking LCM over here. 4AR divided by what is this, r square minus a square the whole square, because we have a square, right, square over here, right? So we shall put it over here. Okay, and we can also write this 4ar as 2 into 2ar, right? Both are the same thing, so we shall write it. You'll see the reason soon enough. Since P, the dipole moment, equals to AQ, the charge and the distance, the magnitude of the charge and the distance between them. So what do you see over here? 2AQ. So instead of this, we shall write it as E axial line or axial point equals 2PR. So the R will be remaining. So 2AQ, 2PR divided by 4 pi epsilon naught into R square minus A square the whole square. Since R is very much larger than A, you can obviously see it from the diagram over there, we can neglect A. So we are neglecting A, so 2 into 2 4 r cube, r power 4 we will be getting r power 4, so equals 2 PR. This r will be getting cancelled. 2 PR divided by 4 pi epsilon naught r4, r raised to the power 4. So r cancel, so r cube. So E vector equals 2p by 4 pi epsilon naught r cube. Since this is in vector form and this is in scalar form, we shall add a cap to denote the direction of this vector. Scalar. I'm sorry, I'm very sorry. Okay, I'll let you take a look at this whole thing.